All right, so I forgot to record the other one, so let me show you the work through real quick for the other problems, just for the recording here. The first problem right there, power rule, work it through, right? Multiply and subtract the power by 1 when you take the derivative. Second problem, right? Rewrite your variable so that you can use the power rule. Makes your life a little bit easier. For the third one that we just did, same thing. It looks a little bit more complicated, but as long as you can rewrite that variable into a power rule, it's still the same type of derivative, and then just simplify it if they ask you to. And in this case, they did. All right, let's keep going. Next one up. Looks like a simple power rule problem, but it's not, right? It is not a simple power rule problem because hopefully you can see that I have a single function here multiplying with another function, right? And since the functions are multiplying with each other, I can't just use the power rule and be done with it, right? I have to use the product rule, right, along with the power rule. So the derivative of f of x is going to equal to the derivative of the first function. This is where I use the power rule right here. Derivative of the first function is going to be 4x plus 0, so that's the derivative of the first, times the second function, which is sine of x, plus the derivative of the second function. Do you guys remember what the derivative of sine is? Do you remember your trig functions? What's the derivative of sine? Cosine. That's right, Juliet. That's right, David. That's right, Monica. Good. You guys still remember. Derivative of cosine is sine. Oh, I'm sorry. Other way around, knock me. Derivative of sine is cosine. That is right. And then you take that and you multiply that with your first function, 2x squared plus 4. Right? Beautiful, beautiful, beautiful. This one says to be written in any form. I would stop here. Man, I'll just turn it in like this. This is perfectly valid. You do not need to simplify that any further. It doesn't say to. Right? And if you really wanted to, just be careful with your simplification. I would simplify the 4x with the sine x if you wanted to. But I would not distribute this. Even if I was simplifying, I would just leave that as is. I would leave that as is. Maybe write the polynomial in front because, I don't know, there's no real reason. Only if you want to. Use your parentheses and whatnot, but I'd leave it in the box form. Okay? Product rule in a nutshell, right? Don't forget the product rule, okay? If the function f of x is built up of two functions multiplying with each other, g of x times h of x, you got to be able to identify that, by the way. You see there's no dot written there. They're just written next to each other. You have to be able to see that this is a function times another function. Remember that rule. It's the derivative of the first times the second plus the derivative of the second times the first. Boom. All right, power rule in a nutshell. All right, let's keep going. This one is if you look at it closely, it's a function dividing another function. And I can't rewrite this into a nice power rule, right? Because there's a variable in the top and a variable in the bottom being separated with plus signs. So you can't just simplify this out, right? And hopefully use the power rule. So we got to use the quotient rule. We got to use the quotient rule, right? Oh, that hurts me a little bit. I hate simplifying quotient rules, but it's, shouldn't be that bad. Let's go ahead and take a look here. This is going to be my high function. This is going to be my low function. And if you don't remember, the derivative of a quotient rule is just going to be low d high minus high d low all over low low. Some of you guys still remember, right? I feel like just because of how ridiculous the saying is, this is probably one of the few things that you will remember after my class. You're going to be like, well, what do you remember from calculus? A low d high minus high d low over low low. What does that mean? Something. I don't know. I don't know. Maybe I'm wrong. You're going to memorize this all. You're going to not memorize. You're going to learn this all. You're going to remember this all, right? Right? So there's my high. There's my low. Let's go ahead and take a look at that. So low is going to go first. So low is 3 plus 2x times the derivative of the high. Derivative of the high is going to be, it looks like 9x squared plus 5 is going to go away, minus high, which is 3x cubed plus 5 times the d low. The d low looks like it is just 2. That's easy enough. All over low low. And in this case, low low is 3 plus 2x squared. Okay? Again, if it didn't say simplify it, I'd leave it there. I'd call it a day. But since it says simplify, I have to multiply certain things out to see if they can combine. Now, this is like algebra work, though, okay? So distributing here, 9 squared times 3 is going to be 27x squared, 9x squared times 3, not 9 squared. Come on, complete your sentences. 9x squared times 2x is going to give me plus 18x cubed, right? Double check my math, by the way. Hopefully I'm doing this correctly. 2 times 3x cubed is going to give me 6x cubed, but there's a minus in front there that you also have to distribute. So 6x cubed minus 10. Did I do that right? Does that look okay? I'm not going to distribute the bottom because there's no point. It doesn't combine with anything else. There's no pluses or minus with it to simplify. So I don't need to combine the bottom. I can leave that as 3 plus 2x squared, and that is considered simplified. But if there was a plus something next to it, like plus something else over here, then I might have to distribute it so that way I can combine them together to see if it simplifies any further. But in this case, there's nothing there, so I just leave it like that. Almost done. Y prime is going to equal, combine like terms, 18x cubed minus 6x cubed is going to give me 12x cubed plus 27x squared minus 10 all over 3 plus 2x squared. And that's your answer right there. How you guys doing? Is this all coming back to you? Does this, or are you just, you know, on a level of like, how do you guys feel about this? On a level from 1 to 5, like 1 being like, oh my gosh, I don't remember any of this. 5 being, you're a master at this. How are you guys feeling about this? I plugged that in, but it told me it was wrong. Let me go take a look. I can check for you. It's all coming back to like too much. All right, David. I don't know about that comment. All right, let's see here. Let's take a look. Calvin says you entered that. Let me take a look here before I move on, because that could be the case. That could be the case. Period 3. There you are. Calvin. It says you got it right. Oh, wait, no, it says you got nothing. What? Never mind, I forgot the minus 10. Ah, okay. Well, I'm also more confused as to, is it not updated yet? I can't actually see your responses on there just yet. Anyways, no worries. Let's keep going. All right. This problem right here, is this the last one? Yes, this is the last one. This right here, please be careful with these problems. We just did product rule and we did quotient rule. When you look at this problem, this is a common mistake. Please don't look at this and say, oh, it's cosine times 4x cubed, right? It is not a product rule. And that's the most common mistake I've seen when dealing with trig functions. They see the parentheses next to the trig functions and they think trig function times this stuff. It's not. It's the trig function of this stuff. It's a function of it, meaning there's a stuff inside another function, which makes this the chain rule. This is the inside, right? And this right here is the outside. This is actually nested inside your trig function, okay? So you got to make sure you understand that this is not a product rule. This is a chain rule. I know it's been like a semester in, and it's a common mistake. I know that a lot of people still make this mistake, so don't feel bad if you still are not able to see it, but you got to let me know if you can't. And we got to try to work at some more problems to get you to see it. But yeah, anyways, let's go ahead and take a look here. So we have here the inner, right? The inner function is 4x cubed. So the derivative of that is going to be 12x squared. The outer function is going to be, now you could just do cosine of some stuff and then attach the 3 as a coefficient, or you could write it as 3 cosine, but I'm just going to write it as cosine, right? As cosine of some stuff. Derivative of the cosine is going to be negative sine of said stuff, right? And what's the stuff that goes inside there? The stuff that goes inside there was what was originally in there, which is 4x to the third, right? So this will be 4x to the third that's in here. So when I take the derivative of this dy dx, it's just equal to the derivative of the inside. Oh, wait. So here's my issue. If I didn't write the 3, I got to make sure I include the 3 here. So it's just a coefficient. It comes along for the ride. Take the derivative of the inside, which is going to be 12x squared, times the derivative of the outside, which is negative sine of 4x to the third. And that's it. What do you do with that 3 and that all that stuff? You can multiply it all out if you want, or you can leave it like this. If you want to simplify it, the negative sign right here multiplies with the 12 and multiplies with 3, so you end up with negative 36x squared times sine of 4x cubed. And I would leave it like that. If you want it simplified, that's what you should get. But this is perfectly valid as well if you want to leave it here. If you wrote it a little bit differently and you took the 3 along with the cosine, right? If you wrote the outside as 3 cosine of some stuff, which is perfectly fine, the derivative of that is going to be negative 3 sine of some stuff if you want to do it that way. If you want to, you don't have to, but that is one way of doing it. All right. Hopefully, like David saying, it's all coming back together. Not like that though, but coming back together like something more school appropriate. Hopefully it's working out for you. If not, you got to let me know. Like I said, I have office hours today at 1. Please stop by. We can practice some problems together if you need more practice. That's the only thing that usually helps with these derivatives, is just doing more of them. I know that sounds weird, but it's like the one thing that drill and kill actually does work pretty well with. You just do more of them, and eventually you will get them. You will get them. All right, that's that right there. Okay. I wanted to go over a lesson that we went over at the end of the first semester, but we didn't really do much on, right? Which was calculating extreme values of a function, right? So 4.1. These notes are still up from last time. I'm not going to go too deep into it, but just remember, right, to find a local max or a local min. I forget how to do this when I get accepted to alchemy. You'll be surprised. It seems like you'll forget it, but then you take calculus again, you'll be like, yeah, I still can't remember how to do it. All right, so remember, if you're looking for max and mins, on a closed interval, right? If you're looking for max and mins on a closed interval, you got to check the endpoints, because sometimes the endpoints, right, are all the way up or all the way down, so they could be your max or your mins. If your endpoints are open, though, and they're the highest point, there's a possibility that it does not have a max or it does not have a min. Yeah, those are possibilities. Okay. Now, let's say you're looking at a function and you're trying to figure out if it has a max or a min, right? You could do look for them by looking at these critical values. And remember, the critical value, right, is just where the derivative is equal to 0 or the derivative does not exist, right? So at those points where the derivative is equal to 0, we have these little humps. You see that? They happen at a peak here, either at the top of the hump or at the bottom of the hump. You see that? And at those critical points, it's a possibility that you have a max or a min, right? But you for sure could also have a local max or a local min, right? Which is different from a global max or a global min, right? The global max, if you think about it, it's the absolute max of the problem. It's the highest of that function. If you have a local max, that means that it's the highest point within around itself, right? So if I was drawing a function and I had something that looked like this, right? And let's say it ends over here and it ends over here. We can clearly see that this is the absolute max, right? And we can clearly see this is the absolute min. But you see this point right here? This point right here, that's still considered a critical point, right? Critical point because the derivative is equal to 0 there. But it's also considered a relative max. It's maximum relative to the points around it. You see that? It's the highest point around itself. Okay? And that's the same as this guy over here. This is also a critical point because, again, the derivative is equal to 0 point. But we call that a relative minimum. Again, because it's the lowest point relative to everything around it. Okay? So you might be asked to find things like this, like what's the relative max, what's the relative min? Is it the absolute max? Is it the absolute minimum? And the easiest way when you do these problems is basically just find all the critical points. And how do you find the critical points? Looking back at our work here, you take the function that they give you, take the derivative of it, and set it equal to 0. When you solve for that, what you're essentially finding is the x values where the derivative is equal to 0. And we just labeled that your critical point. And once you have your critical point, you kind of just test the values there. You evaluate it at the critical point to see what the value is, and then you test the endpoints to see if this is the absolute minimum or was it just a relative minimum. Okay. I'm going to give you some. I think we got to do some practice problems on this, but we'll come back to that eventually. On that right there. But that was pretty much the last lesson that we did, and we didn't do much more on that. It does build up on it later, but we'll do that later on. But that was pretty much it for 4.1. Okay. All right. 4.2. Let's take a look at that one. So I want you guys to do this for me here. You guys go over here onto the daily agenda, and you'll notice that 4.2 for the notes for this one is actually going to be a worksheet. So I'm going to go ahead and click on that for you right here. All right, and it's this guy right here. So I'm going to put that into the chat. And if you guys could, please open this up. You can do these notes using Kami. And if you don't like doing Kami, you can do it on your own paper. It's going to be easier on Kami just because it's a PDF, and unless you print it out, it's going to be a little annoying. But you can hand draw it, you can do it, and you can watch the video and come back and fill out the notes that way. But yeah, let's go ahead and take a look here. It should look something like this. That's not what it should look like. Let's close you. There you are. Haha. There you are. It should look something like this. You guys see it? It says worksheet, but it's going to be your notes for 4.2, which is introducing the mean value theorem. You'll be looking for the mean value, if you know what I mean. We're not going to be able to finish this today, so don't worry. Just when you finish what you can, just click the save button, and it hopefully will save for you. Wait, do you have a save button? I'm assuming you do. So hopefully you do. Yes, you do. Awesome, awesome. So just save it, and then we'll reopen it next time, and then you guys can continue where we left off. All right. So here's what I want you guys to do right now. Here's what I want you guys to do right now. We're gonna do. Let's take a look at these first two problems right here. Okay. And I'll show you how to do it on Kami if you guys are uncomfortable with it. So first, I'm gonna just zoom in here and just read these directions here. For each graph, we're going to draw a secant line through the 2 points on the graph corresponding to the endpoints of the indicated interval. So, for example, number 1 right here, the point is not 0, 3. The interval is from 0 to 3. So where are the points? Where are the points? Well, I have one point right here at 0. And I have another point at 3 right here. So when it says to draw a secant line, just connect the 2 lines through. And that's all it's asking you to do, right? And if you want, you can use their line tool. I believe they have a line tool. I think it's supposed to be 45 degrees. Boop. And it goes through to the other side as well, I believe. That's cool. Yeah, that's kind of neat. I think that's easier than my other tool. But yeah, so that's going to be that one. And on the indicated interval, draw any tangent lines to the graph of the function that are parallel to the secant line that you drew in part 1. So once you draw on this, right, look between here from 0 to 3 and see if you could find any tangent lines that are parallel to that. So for example, what is a tangent line, right? A tangent line just is a line that touches your function once, right? So for example, this right here is let me try that again. This right here is a tangent line, but that's clearly not parallel to that secant line, is it? So if you guys could, can you draw where would a tangent line look like that's parallel to it? And I think it's going to look something like that. Something like that, right? For each tangent line from part 2, estimate the x value or the x coordinate of the point of tangency. So it's looking like that one is parallel. That looks like it's happening at about, so it looks like at about 1.5, I'd say. How are you guys doing? Have I lost any of you guys yet? Does it look simple enough? You think you're all right? If you're lost, let me do it again. Let's do it again. So all I've done, right, for the directions that it told me was to look at the interval that we're focusing on, which is 0 to 3. So here's 0 and here's 3, but the point on the function is up here. What they asked me to do after we drew those points was to draw a secant line, right? Draw a secant line. So I'm going to draw a secant line by cheating a little bit here and using this ruler that doesn't want to work correctly. There we go. Right there. And I'm just going to draw my secant line like so. Boop, bam. Okay. What I need to do now, oh, actually I can cheat even further, is look in between here to see where can I draw a secant line that's parallel. And if you see here, if I have my ruler right like this, I can just move my ruler along right here. And it looks like, hey, check this out. You look, bam. That looks like it's going to be a tangent line right about there, isn't it? Right about there. And, all right, it's going to be parallel because I just moved the ruler along just like so. I'll just draw my, bam, like that. Oh, that's actually terrible, Knock Me. How could you cheat and still get it to look ugly? Let's try that again. Bam, like that, and then boom. How's that? Is that better? Oh, that's pretty good. I like that. That's pretty good. So how do I know, by the way, that the x value is 1.5? Well, you just look at the bar, right? Here's 1, x is equal to 1, x is equal to 2. The point where it looks like it's tangent is like right there, isn't it? And right there is at the x value of 1.5. And that's how we got that, right? That's how we got that. How you guys doing? You doing all right? Does it make sense on what I just did there, or does it still look like voodoo magic that doesn't make any sense to you? Let me know. Hopefully it looks all right. All right. If that's the case, can you guys try number 2? Try it out. Try number 2. And if that's too easy and you've already done it, try number 3 and try number 4. See how many x values can you get for those right there. Right, so go to number 2 right now. Try it out. Draw a secant line for me for number 2 on the interval, right? On the interval from 2 to 4. And if you're struggling with this, I'll help you out right now. So 2 has a point right there. 4 has a point right there. Draw a secant line that connects those 2 red dots. After you do that, draw a tangent line that's between those 2 red dots that's parallel to the line of that red dot. And then try your best to estimate, where is that blue dot that's going to be between those 2 red dots so that the line you draw is parallel to this. I'm looking at your guys' work on Cami right now, for those of you who have it open. Looking at some of your work here. Let's see here. Jocelyn, that's beautiful. That's beautiful. Good job on drawing those lines. Keep going. Good job, Kaylee, on the 2 dots you have there. You'll be drawing that line soon enough. I was like, Erica, it's beautifully drawn. Oh wait, that's my viewing. I'm gonna open it up on Cami. This is gonna be graded, by the way. This is gonna count towards your participation notes. So it's not homework, but it is notes. But it is gonna be counted towards your grade. I think it's like 10% of your grade. So please make sure you're doing this along with me. It's not based off of right or wrong. It's just based off of you following along, right? Angela, good job. That's a beautiful line. Good job. Let's see what else we got here. Oh, some of you guys don't have it open yet. What's going on here? Or maybe you have it open on another screen that I can't see. I wonder if Ilias is actually here or is he just asleep? Mark, what are you looking at? Are you having trouble finding what we're doing right here? Do you need the link again? I can post the link again in the chat. Oh. Joe is dealing with authorizing the Google Drive. Is it not working? Oh, there it goes. Okay. All right. That's that. So double check. Anyone else having some issues? Let me know. All right. So how'd you guys do for the 2 dots on number 2, right? You should at least have gotten this far, right? I'm drawing a dot at 2, 4, not literally the point 2, 4, right? Even though that's the first dot that I have there. I'm drawing a dot at x equals to 2, and I'm drawing another dot at x equals to 4. That's what I'm doing, okay? That's the interval I'm looking at, from x is equal to 2 to x is equal to 4. And then I'm going to draw a secant line connecting those 2 dots, right? Connecting those 2 dots. So let's go ahead and connect these 2 dots right here. That looks good, right? And then I go, bam, just like that. No, that missed. Let me make that a little bit better here. Boom, let's go with that. And boom, how's that? How's that look? That look good? All right. That's all it's asking you to do. Step 1, draw 2 dots at the endpoints for that interval. Draw a secant line through it. Right. Step 2, find a parallel line, a parallel tangent line between those 2 dots. So there's parallel lines all the way out here. You see that? Like if I drew a line out here, right, this would be considered parallel, right? And so with this, and so with this, right, these are all parallel lines. But I want it parallel and tangent and between those 2 points. So I'm going to go ahead and scroll this over right here like so. Bam. And I'm going to draw my tangent line like that. Boom. Where does it look like it's... No, that's too close, isn't it? I can go a little bit better. Let's go a little bit better. Let's go... Looks like there, right? Let's go there. That looks like it's a better tangent line. And that looks like it's happening right here. You see that? You see that dot I drew right there? That blue line you can see is parallel to this red line. You see that? Boom, boom. And you're like, knock me, we don't have rulers. And I understand. You just sketch it as best you can. Traditionally, I would have this printed out for you, and we'd do this in class, and you'd have rulers in class, but, you know, online stuff. But try your best. And if you notice, where's that dot at? Where is that tangent line parallel to those 2 points? It's happening. That's right, Monica. It's happening at x equals to 3. Very good. And that's it. That's all I'm asking you to do, by the way. So for this worksheet, I want you to go through here and just do that for me. So if you want to do it on paper, you could print this out and you could do it on paper, but you're going to go through here for numbers 1, 2, 3, 4, 5, 6. And we'll keep going after that. But can you guys get these first 6 for me? So let's see what you guys get here. So that's the first 2. Okay. That's the first 2 right there. Done. If you guys are getting it, just keep going along. Go all the way up to 6 for me and see how well you can draw those out. And then we'll talk about the second section after that. But let's go ahead and take a look here. Right? Nothing fancy, nothing crazy, right? Here's this one. Number 3. On the interval from 0 to 4. Well, what was the dot at 0? The dot at 0 is right here based off of this function. Where's the dot at 4? It's right there based off of this function. what does that look like? Well, it's just a straight line. Well, they're all straight lines, right? Secant lines are all these straight lines, but it's right here, right, at 0. So boom, there's my secant line. Can you guys find where the tangent line is? It's going to be parallel to that. That's not tangent. That's not tangent. That's not tangent. But right about there. See that? Right about there. That looks like it's going to be tangent and parallel at that point right there, which is this point at this very peak right here, which gives me the x value of 1, 2. X value of 2. You guys doing all right? That was number 3, by the way, that I did. Hopefully you guys can copy it down. Or you already had it done because you guys are getting it. Try it out, guys. Try it out. That's number 3. If you are getting it, try number 4. Try number 4. Number 4 is a little bit more delicate. Well, not delicate, but a little bit more. A little bit more. Anyone having issues with opening it up on Cami? That's what I like to know as well. But it looks like most of you guys are, but there's a couple of you guys who are just watching me. And I'm assuming you have it on a different computer. That could be the case. Oh man, Kimberly, good job on those lines. Good job on those lines. Let's see here. Who else we got here? Oh, good attempt, Leslie. Good attempt. Good attempt. Be careful where you put those dots, though. But that's a good attempt. I like it. So we're looking at number 4 for some of you. Some of you guys are already ahead and go off to number 6. That's beautiful. That's awesome, by the way. And if you finish number 6, you can try part 2. Part 2 is a little bit different. Okay? But now be careful with this. Okay? Be careful when you draw these dots. Okay? -1, 3. Again, I can't stress this enough. This is a common mistake. -1, 3 is not asking you to go to -1 and 3 and you make a dot here. That's not what that's saying, right? This is the interval from x equals to -1 to x equals to 3. Well, x equals to -1 is right here. But the dot that exists at -1 is not up at 3. It's actually down here at -5. That's where the dot is located. How do I know that? Because that's based off of the function that's given to me, right? So it's bam, right there. Okay? The second dot is at x equals 3. Where's that? And that's right there. Boom. That's how I'm drawing my 2 dots to draw my secant line, by the way. I'm going based off of the information that they give me for the interval, and I'm drawing it based off the function that they have drawn for me, right? That's all I'm doing, okay? Now, the next thing I do is get my line function, and I connect the 2 dots together, right? Connect the 2 dots together. See, that looks pretty good, right? No, that should be like maybe that right there. No, that's too much. 64. 64 degrees looks better. Again, it doesn't have to be perfect. Doesn't have to be perfect, Nakmi. Just draw it as best you can. There you go. There's my secant line. That's what that should look like for number 4, right? Then I'm going to do the same thing and look for a tangent line that is parallel to that. And I'm just going to cheat by using this ruler by sliding it along here. And it looks like where is it going to touch at only 1 point? It's going to happen right at that point right there, doesn't it? Looks like it's going to be right at that point, which is right about approximately at x equals to 1. Okay, approximately x equals to 1. So keep going through there, guys. We've gotten 1, 2, 3, and 4 done, right? Hopefully you got the same answers as I did. Number 1 was 1.5. Number 2 was 3. Number 3 was 2. That sounds ridiculous. And number 4 was 1. Right? That looks like it's where it's happening. I'm going to be grading to see what you guys got for number 5 and number 6 when you guys submit this. But don't submit this today, right? We're still working on it, so just save what you have so far. So yeah, get these ones done as well. So this one's from 0 to 5. If you need help here, the 0 is right there. X equals to 5 is down here. So draw yourself the secant line based off that. This is going to go from 1, which is right there, to 4, which is right there. So draw your secant line and find your tangent line for that one as well. Okay. Now the last, do that on your own. Get that drawn for me and tell me what those X values are. Okay. Now I'm going to move on to section 2 right now. So if you haven't done 5 and 6 yet, just put that on hold right now and follow along with me real quick here to number 1 and 2 from section 2. Right. So if you're still working on it, just put these on hold right now. If you haven't done 1, 2, 3, 4, 5, and 6 for the first section, just put that on hold. I have 1 through 4 already done. You can go ahead and copy that down from OneNote later on. But can you guys come here to worksheet number 2? And we're going to start developing the hypothesis for the mean value theorem based off of these examples right here. Now, these functions for number 1 and number 2 look the same, but they are not, right? Can anybody spot the difference between number 1 and number 2? Anybody spot the difference between the functions for number 1 and number 2? They look almost identical. For number 2, the 3 is not included. Cool. The 3 is not included in number 2. You're close. You're close. You're close. The 3, the X value of 3, or I'm sorry, yeah, the X value of 3 or the Y value of 3. You gotta be careful there. The 0.1 comma 12. That's right, Ryan. That's right. The 0.1 comma 12 is not on the line, right? Instead, the function is not defined at 1 comma 12. It is defined at 1 comma whatever that blue dot is, right? Yeah, y equals 12 has an open dot, whereas number 1, y equals 12 has a solid dot, meaning it goes through that point, right? So number 1 is a continuous function, it looks like, for what we can tell, right? For the interval from 1 to 3. But the interval from 1 to 3 on number 2 gives me a little bit of an issue. But that's okay. That's okay. It exists, right? It exists. So when I'm going to follow the same rules as I did for the first part of the worksheet, which is connect the 2 dots with a secant line, right? So I'm going to go ahead and do that. I'm going to draw my secant line right here from 1 to 3 like I've been doing, right? From 1 to 3 like so. Right there. Yeah, that should do it. I'm gonna go ahead and draw my secant line like so. Boom. Just like that. And I'm gonna move my ruler over here so I can find a tangent line that's parallel. That looks like it right about there. Boom. That looks like it's happening right there. Well, what would you guys estimate? It's not asking me for what the X value is anymore, right? Read this. What does it say now? I'm looking for the number of tangents that are parallel to this. I know it only says number of tangents, but how many tangent lines can you count, by the way, for this one? How many tangent lines are there? There is exactly just 1, right? Now check this out. I think this is pretty neat. For number 2, the function is not a nice continuous function, is it? It has that hole there. It has a jump discontinuity over there at x equals to 1. So my secant line for this one right here, would you guys agree that the secant line for this one right here would look something like this? Right? There's my secant line. So I'm going to leave this to you guys. How many parallel tangent lines are there from 1 to 3? How many parallel tangent lines are there from 1 to 3? Juliet's going 10. Are there? Where is one of the tangent lines of those 10 that you see from 1 to 3 here? Tell me a position. Where on this interval right here, from here to here, right? From here to here, on this orange line, do you see a tangent line that's going to be parallel to this red line down here? From here to here. Like the x value? Yeah, sure. Give me the x value. Where do you see it parallel? And remember, it has to be on this interval from here to here. You guys see any of them? Is there any that are parallel to this red line down here? Are there any? X is equal to 1? I don't think that is, okay. I don't think that's parallel, right? That right there is not a tangent line, by the way, right? That right there is not a tangent line, right? If I were to draw this right here, the tangent line that's occurring at x equals to 1 would look something like this. God, that's terrible, Naki. Can you do that a little bit better? It looks something like that. I missed completely. Like that. like that. Jeez, Naki. Yeah, so that tangent line is not parallel to that red line, but that there is a tangent line there, right? But it's not going to be parallel to this red line right here. So my question still stands. And Brian, that's a good question. There are none. Actually, I think that I would say that's a good answer. Yeah, there are 0 tangent lines that are parallel to that one in this case. Okay, there are 0 tangent lines that are parallel in that case. All right. I'm going to ask you guys to try the next 6, 7, 8, 9, 10 problems. The next 10 problems for this. And that's going to be your homework for today. All right? You're going to go through the rest of these. And on the interval that's given to you, right, do the same thing. But this time, you're not going to tell me where the tangent line should be located. I want you to tell me how many tangent lines are there that are parallel to those secant lines. So for example, right here is 0 to 3, right? Here's 0 to 3. And I want to draw a secant line from here to here. Like so. Right? How many parallel tangent lines do you guys see here for number 3? How many parallel tangent lines do you see here for number 3? How many you guys got? How many you guys got? Sydney's going 2. Question mark? Take the question mark off of that and you're right, Sydney. Yes, 2. There are 2 there. How are you guys doing? Are you guys okay? You guys understanding? Yeah, have more confidence in yourself. You got it. You got it. There's 2 parallel tangent lines between 0 and 3 on that problem. Okay? And that's going to be pretty much it for right now. So don't submit again, though, like I said. But I do want you to complete up to number 10 for me. Up to number 10 for me. So go through there and look on the intervals that are given to you and see how many parallel tangent lines can you draw. Right? How many parallel tangent lines can you draw based off of that? And if you really wanted to, you can try to answer these questions here. This looks different from how it looks like on yours. So let me go down here, right? After you do number 10, right? There is a set of questions here. And I only want you to answer up to this one right here if you want to, up to this one. So which graphs are continuous on the indicated intervals for the second part? Don't do numbers 1 through 6 for part 1. Just do from 1 to 10 for part 2. So answer the questions, which graphs are continuous, which graphs are not continuous, which graphs are differentiable, and which graphs are not differentiable. Okay, so that's going to be your homework for tonight. If you guys could go all the way up to number 10, draw the secant lines and count how many tangent lines you can find. How do you find the tangent lines? And how do you know what direction they're pointing towards? So think of it in terms of the limits definition of a tangent line. See what it's going to be equal to as it approaches from both sides. So what I did over here, which I kind of just cheated by using the ruler. But the idea is if I was to draw a tangent line by approaching this point right here from the left and this side right here from the right, and I approach this tangent line right there, this is the line that should be formed as I get closer and closer to it. As what they're facing, you kind of just practice sketching your tangent lines. Like, I'd say that's a tangent line, right? you can sketch and say that's a tangent line, but you're just looking for the one that's there. Wait, what's the homework again? Finish off these sketches, Kimberly. That's all I'm saying. So for this worksheet that you're working on right now, where it says worksheet 2, hypothesis for the mean value theorem, finish off these sketches for numbers 1 through 10. And that's going to be it for me today, guys. Don't submit it. Like I said, we're going to be going over it in class still, but you need to do them beforehand so that we can do the lecture part next time. All right, guys, that's it for me today. Thanks for listening through. Please stop by later on today for my office hours if you are still struggling with derivatives. If you're still struggling with derivatives, you're not going to have a good time for this next section. So please stop by for some help if you need it. Other than that, guys, have a good rest of your day. I'll see you guys on Thursday. Bye-bye, everybody. Bye-bye. So long. Farewell. You too, guys. Have a good day. Till Thursday.